Welcome everybody to this seminar. My name's Professor Peter Taylor. I'm from the University of Leeds and I'm one of the investigators on the H+C Network Plus for the decarbonisation of heating and cooling. Now this event is organised by that network as part of a series looking at the different challenges of decarbonising our heating and cooling sectors and behaviours. And this month we're delighted to welcome speakers from both Cardiff and Leeds universities who will present their research on different aspects of sharing heat. And we're very grateful to our presenters for providing their time today. So our second presentation is from Dr. David Barnes from the University of Leeds, where he's a research fellow and he's a researcher and policy specialist in heat decarbonisation. He completed his PhD on thermal energy storage deployment in the UK in 2022. And this explored issues such as national and local policy, business models, and organisational decisions. How these affect local implementation of thermal energy storage in low-carbon heat systems. And his postdoctoral research is concentrating on policy and engagement. And alongside his academic and professional work, he's also a local climate and social justice campaigner, policy and other issues. David, all yours.
Thanks, Peter. Hi, everyone. Yeah, thanks for the introduction, Peter. I'm hopefully kind of quite aligned, but quite a different take on heating, decarbonisation, and heating technologies and sharing heating systems. So yeah, as Peter said, I focus much more on the kind of policy side, the non-technical aspects, essentially, considering all the things that we need to work out, how change is actually going to happen when it comes to heating decarbonisation. So I'm going to start off with, I don't think I need to tell anyone this, but just as a bit of a way to frame this conversation is, this is where we are in the UK in terms of our different heating systems. And you can see how incredibly reliant we still are on gas boilers. Other options, as I'll come to in this talk, are starting to make some headway, but you can see what kind of scale of the challenge we've got. With heat pumps, they're only on 1%, district heating on 2%. Gas boilers, obviously, the absolutely massive lion's share of the UK's heating systems, and you can see how poorly we fare in comparison to a range of other countries there, with only the Netherlands being more reliant on gas than we are in the UK. When policymakers, when people are generally thinking about how we're going to decarbonise heat, there's a few options that people go to. The main one that you will hear about in the news is heat pumps. Specifically, I'm going to start with air source heat pumps. And the government has a target for installing 600,000 a year by 2028, and we're currently tens of thousands, so we're way off that. This is essentially a single ground source heat pump system. There's two types of heat pumps we can use: ground and air, and I'm including water source within ground source. But essentially, you can see here that it's quite a lot of disruption. It needs some outside space. So this is part of the reason of looking at sharing systems, which I'll come on to. Heat networks. Now, here's a picture of a heat network being installed, and you can see these whacking great pipes in the ground that will connect a single heat source, preferably that is a net zero compatible heat source like a heat pump. But what we've got in Leeds, for example, we've got a big energy from waste plant, and while no one, I hope, would support new energy from waste plant, the idea is here that heat is going to go to waste unless it's used. So in Leeds, what they're doing is pumping that heat around the city, and it's serving many thousands of properties, mostly social housing and lots of civic buildings, with plans to expand it hugely. And then the question mark at the end is hydrogen boilers, and there's a whole challenging situation around those who believe that hydrogen is the future and those who believe that hydrogen has no place in heating. And I'm happy to talk more about that if anyone has sort of specific questions they want to ask about that. But I've included some of that kind of narrative in my research. So what we hope the future looks like is these happy people. Yeah, these are all heat pumps, air source heat pumps here. These happy people standing by their heat pumps. But what you can see is these heat pumps do take up quite a lot of space. You need a property that can actually accommodate it. Okay, and not everyone has that. And not everyone lives in, heat networks. They're probably going to grow outwards from urban centres because you need the density normally to make them work because of those high temperatures, those big pipes. You need a density of properties of different, preferably of different types within an area. And these pictures here, I put a more kind of semi-urban, or maybe on the edge of a city where, moving into more kind of residential areas where there isn't necessarily the scale and density of heat demand. So what's the solution in those situations? So this is where the research that I did during my PhD and then carried on after that, looked at shared ground heat exchange. And that follows on quite well from the talk we've just had. And essentially, this is a type of system where you have a ground loop. It's also called a shared ground loop, an ambient heat network, 5th generation district heating and cooling, street by street district heat network. There's so many different names for it, and that's part of the problem, is that it's not clearly defined. But essentially, as you see in the bottom image, some kind of ground array, a number of boreholes. They can be any type of boreholes, but they're normally the ones being installed at the moment a closed loop. But you can use aquifers, whatever heat source you've got available, essentially, and connected together through an ambient, very low temperature heat network to a number of properties with distributed heat pumps, as we heard about in the previous talk. So there's a few kind of defining characteristics of that technology, but I think we've heard enough to kind of understand what that is. So this research that I'm going to mainly be focusing on was kind of post my PhD, but using the findings of the PhD to inform and support this policy engagement process where we brought stakeholders together and explored the technology, what the issues are, why it's not happening at a greater scale. And part of this work, we did this rapid evidence assessment, and we looked at the various different benefits and challenges that these systems might be able to offer. And one of the key things is, if you're a household, like I am here, like my terraced house in West Yorkshire, my boiler it's time to renew my boiler. And this is a decision households are facing every day. And what do you do? At the moment, I don't really have a choice. Like that image you saw, I don't have anywhere I could install an air source heat pump. And there's no heat network here. And there's not going to be a heat network in this kind of semi-rural area. And so my options are really limited. So an ideal way of approaching this that we found in the research was, if a company, an organization, an entity was able to come and put the pipework in the street, and it just sits there. It sits there waiting for households to make the decision that it's time for them to connect. Then that creates a whole kind of different dynamic of rather than being compelled to, then it gives you the option of saying, oh, right, okay, so it's time to replace my boiler. There's this other option now because they came and installed those pipes recently. Now, that's, of course, an idealized scenario, and there's specific challenges around actually making that happen. But that, to me, is one way that we can start to see like real penetration of these types of systems. But of course, it comes with huge challenges. One of the key things is that the market is very small at the moment, and it's concentrated with really one, but a very small number of firms involved in this. Of course, we need that to grow. We need competition. We need different types of approaches. We need better, higher efficiency systems. But at the moment, it's very concentrated. And that image on the right shows how the government, they really fall between two stools, these systems, because they're not really heat networks, they're not really heat pumps. Well, they're both, and neither in a way. And BEIS themselves admit that they don't really see how they have in BEIS they have a heat pumps team and they have a heat networks team, and these kind of fall between those two. So they've kind of missed out on a bit of the kind of coordinated support that the government's put into other technologies. Thinking about that utility model that I mentioned, like this broadband model where you come along and a company comes along and puts the pipe work in and puts the broadband network in. You've got to make that investable. And that's a real challenge. If you can't compel people to connect to your system, then how do you get your returns? And that's a big challenge. So there may be a role for local coordination on a street by street basis for local authorities or other entities. So there's just things that we explored in our work. This was based on research during my PhD that was looking at, okay, in new development specifically, why in some cases do you get, new development's going to happen and you end up with gas boilers, new development's going to happen and you end up with shared ground heat exchange. Okay, of course, new developments are only part of the challenge, but we're going to have 8 million homes in the UK before 2050. So it is an ideal way to kind of approach this, because if we can tackle new homes, then it does lead into retrofit scenarios in terms of technology getting better and experience and installers, that kind of everything kind of ramping up. So I looked at 30 housing developments, traced them over the course of their kind of planning journey from the start. What type of technology was going to be used, what interaction did they have with the local planning authority, with different planning policies, how they interpreted them, traced that all through, and then looked at what happened in the end. And so you can see that here is just an image to show the different types of systems that I included and how they changed through the planning process and how they ended up. And essentially, there's a few key aspects, which I'll come to over the next few slides. And I'm rattling through these at quite a fair pace. So hopefully this will just prompt some ideas and thoughts and questions that people can raise afterwards. But what I found is that you can drive local change with the right policies in place and with the right approach to supporting developers and enforcing the policies when it mattered. And one key aspect is that developers, essentially, they want to do the lowest cost, lowest hassle thing. And I'll come to in one of the slides to say a bit about why that is. But what I found was happening is that gas boilers have been the go-to technology that developers have been using around the UK, and that's actually moving to direct electric heating. And it's kind of happening under the radar because no one's kind of really planning for that. It's not in any of the policy documents. No one's planning for a future where we're all using direct electric heating, but it's happening right now because these external factors and social and political factors, which I'll briefly touch on. So that's kind of what's happening. So unless the right policies and the right approach to enforcement is put in place, that's probably what we're going to see happen in the UK. So local plans. So local plans are how local authorities develop and implement their planning policies. And they are supposed to update them every 5 years, but it's a hugely time and resource intensive process. So it tends not to happen as often as it should. There's a whole host of these external factors. National government have kind of muddied the water over the years, saying that they can enforce 20% carbon. It can only enforce 20% carbon reductions. Oh no, they can enforce more than that. And then the planning inspector doesn't know what to do, and they challenge it when local authorities try and take kind of more bold steps. Housing delivery targets. So this is an annual thing that planning authorities are judged on by central government, and just taking the Leeds as an example and comparing to the other local authorities. What happens is if they don't deliver on the number of houses, they get put into presumption, essentially, which tilts the balance in favour of developers, even more than it already is tilted in favour of developers. And that means essentially that there's a constant pressure for planning authorities to get things built because they need to pass these tests, as well as all the other reasons that it's important that we have new homes. But this is a part of the challenge why local authorities are reluctant to implement higher standards, because it challenges them meeting this target, basically. There's a kind of technical thing that where in the planning rules tied to national building regulations, tied to standard assessment procedure, is these inherent carbon factors have naturally led towards, in the past, they naturally led towards boilers because gas looked really good, that top one, and electricity looked really bad. Yeah, gas didn't look good, but it looked a lot better than electricity, essentially. And that got more and more out of date, and it got updated recently, and you can see electricity has dropped massively in its carbon intensity now in the regulations. So electricity automatically, so an electrified solution like a heat pump starts to look better. But this on its own won't necessarily change anything, because direct electric heating now looks better than a gas boiler, even though it's only 100% efficient compared to a heat pump at 300, 400, 500% efficient. This is another one that, to touch on that thing that I said about developers, they are almost compelled to do the least they possibly can, because they have this viability calculation. And that means that a developer wants to buy a site, they can offer a certain amount of money, and the amount they can offer is based on this calculation. And if that is based on the income they're going to get or the costs they're going to spend. So they either know they can get more income by building a better development and selling it and selling the homes at a higher price, or they have to reduce their costs. So they tend to reduce their costs. And so unless all developers within an area are held to the same standard, and they know they cannot argue it away, because they will try and argue it away, or some will, unless they know they can't be argued away, then it automatically trends towards the lowest common denominator, and why we don't see better, more ambitious housing developments, or any kind of developments more commonly. Leeds City Council are updating their planning policies to try and address their climate emergency commitments, as lots and lots of local authorities are doing. And they, through engaging them with this work, I actually have done a specific piece of work essentially to try and implement these aspects into the new local plan, which has just finished its second stage of consultation. So that was the old situation. 20% carbon reduction was the maximum they can do. Gas boilers, direct electric heating were permitted, and that's what we were seeing. And these new policies are now based on this research and the work I've specifically done for them to support their local plan. That these are the new policies they put in place. They've banned gas boilers, they've banned direct electric heating, or will have when they come into force. They're preparing for heat network zoning, which I can talk about if anyone is interested. They've put in a requirement that the solution must be the lowest cost and lowest carbon for users. So they actually make developers calculate these things and actually demonstrate that what they're choosing is actually going to be the best for the people who are actually going to live in these properties. Final bit of work I'm going to show you is just about these costs, because when we presented this work and we engaged with government and we engaged with policymakers, we constantly get asked, well, how much do they cost? Surely it's better to build we kept hearing that surely it's better to build a heat network where you can share everything than build these kind of singular, smaller systems where everyone has their own heat pump, because surely that's not the best option in terms of the capital cost. So we've gone away and done a piece of work supported by Bayes, looking at what data we could get. Essentially was looking at local authorities, social housing, private sector. You can't really get much, but like exploring and comparing different costs of these installed systems. And I won't go into this table in detail, but just to say, so you can see there's a number of different projects, and we couldn't include all of them because it wasn't possible to get the cost of data for all of them. But we included what we could. They're the total number of homes you can see there on the second row. And one key thing that came out of it is it's really hard to compare these different systems, because there is no comparing apples with apples when you're looking at these different types of systems. When you've got an air source heat pump, for example, you've got the air source heat pump on its own, and you've got, normally the radiators and pipework inside. Whereas in a heat network situation, you might already have all the internal work, but you might be connecting it to an external heat network that's been built. So that's a different scenario. And then in a shared ground heat exchange scenario, you have to build everything from scratch. You have to build the plant itself, the boreholes, the primary network that gets into the building, the secondary network within the building, and then the wet central heating within the flats or the dwellings, for example. So it's really messy, but just to kind of put a bit of context onto that. These are the costs that we found. I'm still working on these, so these are still taking shape essentially. And you can see here that there's a few key things. So the prices, it gives you an idea of the costs of actually delivering these systems is pretty high, especially when if you're just replacing a gas boiler with another gas boiler. But I'll just go back to that. The bottom there, that bottom row shows that there were frequently lots of other works done at the same time. Often, for example, when local authorities were installing shared ground heat exchange, they were also upgrading sprinkler systems at the same time, and all those costs are wrapped in together. So it's a really tricky thing to kind of isolate different elements of cost. And you can see on this graph the big range. That's the standard deviation. You can see the big range there. Heat networks, for example, so they look the cheapest, but then they've got the biggest standard deviation, so they've got the biggest range essentially around the mean. And you can see the minimum and maximum there for all of these different ones on the right, with the heat networks looking like the lowest cost, but some of them, they go up to £40,000 per property, so the most expensive as well. So we're still crunching the numbers on this, but it's useful to show that there isn't one technology that is currently looking miles better than the others, and there's a huge variety in these different systems and the costs of installing them. So we're still refining and revising that. We're going to take it back to BEIS in a few weeks and explore it further with them. So that work, and then we're going to write up and publish later this year. So that's it from me. So I've rattled through at quite a pace there because I wanted to put it out and hopefully people have some questions and want to talk about it more. Thank you.
Thanks very much, David.